Howdy, 7th grade. Today we're going to be talking about a lot of stuff, so buckle up. We're going to do non-terminating decimals, which is a fancy way to say decimals that don't end, and fractions with negative exponents. We've kind of mentioned negative exponents before, but today we are going to do them with fractions, which can make them a lot more fun. So I hope you are excited, because I am, and here we go. We're going to start off with the non-terminating decimals portion of this. And non-terminating decimals sound complicated, but they're really not too bad. But I want to start off with a terminating or a decimal that does end. So for that example, I'm going to start with a terminating decimal. Let me write that down before I start talking too much about it. And a terminating decimal would be something like 1/8. And the way we would figure out what 1/8 is ask ourselves how many times does 8 go into 1? The answer is 0, so I have to bring in something after the decimal point. 8 goes into 10 once, leaving 2. 8 goes into 20 twice, leaving 4. And 8 goes into 40 5 times, leaving 0. So 1/8 is going to be equal to 0.125. And that is our regular terminating decimal. Something important to remember is that the number on top is going to go inside of our little house that we make for division. But not all numbers are this nice. So for a quick example, I want to try, let's do 2/9. So non-terminating. And we're going to try 2/9. And when we do this, we have to remember to put the top number inside and the lower number outside. 9 goes into 2 exactly 0 times. So we'll put 20 there. 9 goes into 20 twice. 2 times 9 is 18, leaving 2. 9 goes into 2 0 times, so I have to, put the 0 in the wrong place. Put a 0 here. 9 goes into 20 twice, leaving 18. 20 minus 18 is 2. 9 goes into 20 twice, leaving 18. 20 minus 18 is 2. And I think you guys can see where this is going. 9 goes into 20 twice, giving 18. 20 minus 18 is 2. And this will go on forever. So the way we write this when we see a pattern, when we see something repeating, so here the 2 is repeating over and over and over again, is we're just going to write a line over it. So we're going to say 2/9 is going to equal 0.2 with a bar on top. And that's how we're going to write 0.22222. There's one other kind of more complicated non-terminating decimal that I want to show you guys, which is going to be ones that have more complicated patterns. So if I have 2/11 instead of 2/9, I'd be asking myself how many times does 11 go into 2? The answer would be 0, of course. So then I have to do 2.0. 11 goes into 20 once, leaving 9. And if 11 goes into 20 once, leaving 9, I have to ask myself how many times does 11 go into 90? The answer to that question is 8. 8 times 11 is 88, leaving 2. 11 goes into 20 once, minus 11 would be 9. And 11 goes into 90, 8 times, 88, 2. So this will keep on going forever and ever, and we would write this as 0.18 with a bar on top. And it's very important to put the bar on top of the 1 and the 8. That tells us that the 1 and the 8 are repeating. One last one that I want to be able to do is going to be 1/6. Just to show you guys how this works, let me get this in a different color so we know it's a different problem. And we will do 1/6. So the question is, how many times does 6 go into 1? It doesn't. 6 goes into 10 one time, and that will leave us 10 minus 6 is 4. 40. 6 goes into 40 exactly 6 times. 6 times 6 is 36, giving a 4 for 40. 6 goes into 40 6 times. 36. That should say 36, not 34. I confused myself there. 40 minus 36 is 4. 6 goes into 46 times, and this will keep on going forever. So the way we're going to write this is going to be 1/6 is equal to 0.16 with a bar over the 6. And you have to be very careful not to put the bar over the 1 because only the 6 is repeating. So this right here is repeating. And this right here is not repeating. So only the 6 is repeating, only it has the bar, and this is the same thing as this fraction up here. And that is how repeating decimals work. So now all we have to cover for this lesson is fractions with negative exponents. So we'll start that in a nice yellow color. It'll be fractions with negative exponents. And I'm going to start by reviewing a couple things about fractions and exponents in general. So for example, let's do a quick fraction problem with just any exponent. If I have 2/3 squared, what that looks like is that my exponent goes inside and I end up with 2 squared over 3 squared, which is going to be 4/9. And this is how all exponents with fractions work. If I have 1/5 to the power of 10, that would be 1 to the power of 10 over 5 to the power of 10. And I have no idea what 5 to the power of 10 and 10 is, but I'm sure it's a very large number. In any case, the important part is that this number will split itself up into the fraction. Something else that we should remember is when we did negative exponents before, we just put it on one part of the fraction. So if I had, let's say, 1 over 2 to the negative 1, 2 to the negative 1 we said was the same as 1 times 2 to the positive 1. So a negative exponent is same as the positive exponent on the other side of the fraction. Let me do another quick example of that hopefully will look a little bit better. So if I have 3 times 5 over 2 times 6 to the negative 2, this would be the same thing. My 3 would stay the same, my 5 would stay the same, but this time I would have a 6 to the positive 2 and a 2 on bottom. So I just made this exponent here positive to put it on top, and it works the exact same thing the other way. If I have 3 to the negative 2 times 5 over 2 times 6, then I could write this as 5 divided by 3 to the 2 times 2 times 6. So again, all that happened, I took this negative exponent, I made it positive, and I flipped it. So now it is on the bottom of the fraction. So that's not too bad. What it's going to happen when we have entire fractions to negative exponents is it's actually going to become a little bit easier. So looking at this, if I have, let's do an example in red, and I'm going to do 1/3 to the negative 2, the whole thing to the negative 2nd. So we already know that this can simplify to let me start that over. This can simplify to 1 to the negative 2 divided by 3 to the negative 2. And once we have these things to the negative power, so this is equal to 1 to the negative 2 divided by 3 to the negative 2. And we can make those positive exponents by flipping what side of the fraction they're on. So that's going to be 3 squared over 1 squared, which is going to be equal to 9 over 1. And that, of course, is just 9. So we'll do a little bit of a harder problem now. And we'll do it this same way, and I'll show you guys the easy way to do it. So if I have 2/5 to the negative 3rd, this would be the same thing as 2 to the negative 3rd over 5 to the negative 3rd, which is going to be 5 to the 3rd over 2 to the 3rd, which is going to be 125 over 8. And after that you are done. You're probably just going to have to trust me on this number unless you want to multiply 5 cubed, in which case please do check, and I promise that can't be simplified. It's as simple as it gets. So we're going to try this one more time, and what I want to do now is to show you guys the easy way to think about this. So if I have, for example, 3 halves to the negative 2. Another way to do this is just, if I have a negative, to go ahead and flip my fraction first, 2/3, and make it to a positive fraction. So by making my exponent negative, or changing the sign of it, I can flip my fraction. And it goes the other way too. If I had 3 halves squared, I could rewrite that, if I really wanted to, as 2/3 to the negative 2nd power. So I can flip my fraction anytime I want. All I got to do is change its exponent from a positive to a negative, or a negative to a positive. And of course, if I want to solve these, 2/3 squared is going to be 4 over 9, and 3 halves squared is going to be 9 over 4. In any case, there are just a few problems in the practice set that I don't think will be too hard, and I would love to see that at the end of your notes. I will see y'all tomorrow. Toodaloo.